Hey guys, welcome back to the shop. So I want to begin the next phase of the rebuild for the American Pacemaker compound, and that is going to be machining our new bronze Acme nut that is going to match the new Acme screw that I previously machined. If you missed that video, check out the channel. We've got a great video on making a brand new Acme lead screw for the American Pacemaker. All right. So also want to begin by saying that I may sound a little stuffy right now. A few days ago, I had a procedure done. I believe it's called a balloon dilation in your sinuses. And they go up into your sinuses with a balloon and kind of expand your sinuses there. And they told me that it could take maybe up to 5 days before my sinuses are healing and cleared up to where I can kind of breathe normally. So until my sinuses finish healing, I'm going to sound a little stuffy, kind of like I have a cold, but I'm not sick. It's just simply my sinus is continuing to heal. But this is the best day so far. I'm on day number 4, I believe, and I can finally kind of like blow through my nose, and I'm starting to get some good drainage out of there, and things are looking good. So just wanted to make that aware that I may sound a little stuffy during this video, maybe the next couple of videos, I'm not sure. So anyway, let's go ahead and start on our bronze Acme nut. And what I would like to do is I'd like to machine this down in the new shop. We'll use our new Precision Matthews lathe and our KBC milling machine, possibly even the FlexArm. I'm not sure yet, but I want to machine that down there. So I've got some material here on the shelf. Let me take you down there and show you what we're going to use. So this is where I keep a lot of my drops, right down here too. And this area here is a lot of bronze and stainless and brass and things like that. A lot of this is still from, was from the old shop when I was working with my dad, our original shop location. And if you look here, I have a perfectly sized piece of bronze square stock that we can use to make this Acme nut right there. Look at that. It's a little bit wider than this one, but we're going to use this width, which is, I believe it's 1.5 inch square stock. So that's what we're going to use. We'll pull that out, and we will load that up and take it down to the shop and begin our machine work. I'm thinking about maybe even making 2 of these while we're at it. Just go ahead and set up a machine 2. At least if I screw up, I'll have a second one there to continue on. So anyway, there we go. We'll see you down at the new shop. All right, guys, so we're going to be making use of our new machinery today, you know, our Precision Matthews lathe and most likely our KBC mill as well. So I made a little hand sketch of what our Acme nut is going to look like with some dimensions based off of the original. This is what we're going to be copying right there. And then I decided I'm going to be making 2 of these. Not that I need to, but I just wanted to go ahead and make 2 of them. In case maybe the first one I'm working on, I screw it up and I need to make another one, I go ahead and I've got another piece cut, but I'm going to go ahead and machine 2. And if I end up with 2 good parts, I'll use one. And who knows, maybe we'll do something with the second one. Maybe somebody else out there could end up using the second one there. So anyway, I've got the 4-jaw chuck mounted on the Precision Matthews lathe. Now this is not the 4-jaw that came with the machine. This is a Cushman 4-jaw that I bought several years ago, and I've used it on the Victor, and I brought it down here. When I got this lathe, they did not have any 4-jaw chucks available at that time for the lathe, so I just decided I was just going to use that one. But I do I'm going to end up acquiring a new 4-jaw chuck specifically for this machine, so that I got one here and I can take this one back home to the Victor lathe. So anyway, let's go ahead and get started machining these guys. Not going to worry about centering the blocks yet. We just want to face the ends and get them to the right length. Let's get our tool bit centered up first. All right. We'll just give it a measure with the calipers here, and that'll get us close enough where we want to go. 3.903. We want it to be 3.835 as our total length. What I'm going to do is we're going to put a center point where I want my cross hole to be for the Acme thread. Our hole center should be 3 7/30. So I'm just going to look at the scale here, and looks like it's lining up right where it needs to be. 3 7/30. Just going to put a center here because I'm going to be doing this in the 4-jaw chuck. That center hole right there will help me line it up, get it indicated. All right. Do the same thing. This guy here. So we're going back to our 4-jaw chuck to do this. So I've left the jaws where they were when I first faced them off. And I just opened up this one jaw. That way we kind of keep it kind of centered there, although we're going to be offset a little bit. Matter of fact, we'll do some adjustments there, but we'll go ahead and get it just lightly chucked. I'm not going to tighten up very hard on it. Yeah, so we got quite a bit to go. I'm still high there, so I'll tell you what, let's crank it about a half a turn. Still off quite a bit, but we'll go ahead and we'll start our indicated now. I don't have these very tight, just enough to hold it in place. So what we'll do, I've got a live center in the tailstock, and then we're going to use our dead center here, like this. We're going to put the dead center in here. Run our live center up to the back of the dead center very gently. And this is where a spring center works really good as well, but I don't have a spring center with me. And then you can just indicate the center. Go ahead and get our indicator set up. You can see we're out quite a bit. Now we got to go this way a little bit. Trying not to over tighten it because it'll really grab on that bronze. Loosen your lows, tighten your highs. That's all we're doing. You can see we're just about there. Now it's a matter of just tweaking it to get those last few thousandths out, chasing our highs. And that's really good enough. And you just want to make sure at this point that you do have all your chuck jaws tight, that you don't want them loose from your indicating, because you don't want it to push your workpiece in the jaw. So that looks like that's within a half a thousandth right there. So that's ready to go. So we'll just set it up like we are. We'll drill it and then bore it so that we got a nice true bored hole right on size. I am going to go ahead and recut this center just to make sure that we have a nice true center. It should be close, but I like to go ahead and touch it up once we have our part indicated. So we'll center drill it, and then we'll run a drill through there, and then we're going to bore it to size. I've got the machine set at 380 RPM. We don't want to run it too fast because of our offset here, but I think this is going to work out pretty good. And we're clearing. I made sure that we've cleared our carriage, that we're not going to be hitting anything there. And that should be a pretty decent speed for what we're going to do. A little slow for brass or bronze, but it'll get the job done. This is where you have to be kind of careful with a hole going into bronze like this. It'll try to pull the drill in. So I've got the quill kind of locked. Take it in nice and easy until you get to the bottom of your previously drilled hole. Now we should be good to go. So we drilled it about 20 thousandths small. I'm going to use the Micro 100 carbide boring bar here to bore it out. We only got about 20 thousandths to take out of it. And I just wanted, this is something else I want to point out. I wanted to make sure, because we have this, this one jaw hanging out like that, is that we come in there and I'm making sure that this jaw is clearing the carriage. Before I ever turn the machine on, just do it by hand to make sure you have all your clearances where you need, and you're going to be good to go. A little slower than what we need to run, but with that offset jaw like that, I can't spin the machine up much faster than that without getting some vibration. Or you need to put some counterweights on the chuck to counterweight it and equalize the offset. That looks great. Tap size is 570. I'm just using calipers here to get our measurement. It'll get us close enough. So that's 561, so we've got 9 thousandths to come out of it. All right, so our bore is now finished. Matter of fact, I'm gonna go ahead and double check that. It's 570, so we're on our bore size. We got a nice big fat chamfer on this side. And I think I am gonna go ahead and turn it around and chamfer the other side nicely as well. I thought about just leaving it, but I think it would bug me more if we did not turn it around and chamfer this side as well. So it should be very simple. We're just going to put it back in here just like we had it. The jaws will keep it nice and square. And we'll just indicate that. We'll check it, see how far out it is, but we'll probably need to indicate it. Yeah. Got a little bit of run out, probably about maybe 10 thousandths. So let's go ahead and indicate that. Use our ID indicating attachment. This one's actually a Brown and Sharp. If we can get the indicator to position the way we want to, get that guy up in here. Just like that. So what did I say, about 10? That's about 11 or 12, so I was close. This one we want to tighten our lows, loosen our high a little bit. Not giving a lot of pressure on the screw here. Don't want to dig in too hard. Oh, wrong one. Within 1/1000ths. Think that's close enough? I think that's going to be close enough. Actually, I have to pick this up just ever so slightly, maybe a 32nd or so. There we go. That looks good. All right, there's our first one ready for the Acme tap. All right, so our first one is looking good, and it looks like that our workpiece is matching up very nicely to our original sample there. So I think from here, I'm going to go ahead and get the second one drilled and bored. I'm going to do it off camera since you already saw how I did this one. I'm going to do it exactly the same way. And then we're going to take a trip to the home shop. I'm going to use my big FlexArm there, the hydraulic powered FlexArm, and we'll use our Acme tap to go ahead and power tap that that thread through there. I thought about trying to do it in the lathe, but since I got a FlexArm, I know it'll work well. We're just going to go ahead and use a FlexArm to do that. And then once we get those tapped, we'll come back and we'll finish our turning in the 4-jaw chuck. We'll put it in the 4-jaw like that and just simply turn this journal right here. Pretty simple. And then after that, we'll go to the mill. And actually, this is the way I was thinking about doing it. I found a corner rounding end mill, which will be the proper radius for this size block right here, and use a corner round end mill to cut that radius on it. So we'll probably go to our KBC mill and see how it works with this this big corner rounding end mill. Okay, so we're all set up to use the big boy FlexArm. This is the hydraulic powered FlexArm. There's the hydraulic unit down there. And this is the setup. So I just ended up using an aluminum fixture plate there. We've got the clamps bolted to the side to keep any kind of twisting. Then we have our top strap clamp there just to hold it in place securely. So let's go ahead and get these guys tapped.
Well, it's really tight in those blocks right there. There we go. That looks pretty good.
One down, one to go.
Getting a little snug on me. A little bit snug. It's a little too tight.
Go. So what I wanted to try was running the tap back through there by hand, which is what I did there, and it actually worked. It trimmed out just enough. You can see a few shavings right there to where we now have the lead screw is going in there, and it's got a good fit. Now you might see a little bit of wiggling there on there. That is the thread clearance, but I think our thread pitch diameter is going to be just as close as it was on that first nut, because if you try to pull it forward and back there, there's literally no backlash that I can feel with my fingers there. We have to put an indicator on there to see, but that is going to be good. So I haven't done this. This is the first one that we did. I'll set this one up and I'll show you what I mean. Run the tap through there by hand. So it seems like going through there twice is exactly what I needed to do, because the first time, run it through there first, I couldn't get the lead screw. You know, trying to turn it in by hand, I couldn't get it. You know, it's sliding on my hands. But it needs to have just enough clearance to where it can freely screw through the hole. Once we get up there to the full thread profile, it starts getting a little snug on us again. Just making sure I get some lubricant on all the flutes. Saw some chips coming out again. You can see that it trimmed it just a little bit. Blow it off, blow the chips out of it anyway. I think this is going to work. Yep, we're all the way through there. it's good. I'm happy. We have a couple of good Acme nuts here now. By the way, that last clip of the power tap in there, I was having Abby help me, and she accidentally hit the shutter button off during the middle of the video. That's why that last clip cut off, but we did get some, I think we got some pretty good footage there of the tapping to show that. All right, so we've got 2 good Acme nuts there in the works. The threads have turned out great, so I'm real happy about that. I feel kind of relieved that we finally have this part of it done, and we can move on. So we're going to go back to the new lathe, and we'll set this up in the 4-jaw chuck like this manner here, and go ahead and turn down to our 1-inch shank. That's going to fit the compound slide. Once we turn that down, then we will go to the mill and see about milling the radius there in the top. So I had a lot of fun tapping with this 3/4 Acme tap with the FlexArm, so much so that I would like to try it again at some point with this guy right here. So this is an 1.5 inch Acme tap. I haven't even measured the thread pitch to see what that is. I know it's not the same as that. Yeah, it's a little bit more coarse. But this is one that I cleaned up in the evapor rust not long ago, and I need to clean up the shank here. It's got some burrs on it where it got dinged up, but I do have a tap holder for this, and I think this would be a fun test for our big FlexArm in the future. So just something I just wanted to point out. I thought that was pretty cool. So we'll see you back at the Precision Matthews lathe.